We have already learned in a previous lesson that acids produce hydrogen ions when dissolved in water, while alkalis produce hydroxide ions. We can tell whether a substance is acidic or alkaline using litmus solution. Click on each of the droppers to add a few drops of litmus solution to solutions A, B, C, D, and E. Now, can we identify which solutions are acidic and which are alkaline? Yes, we can. Solutions B and C are acidic as they turn litmus solution red. Solutions A and D are alkaline as they turn litmus solution blue. Solution E shows no changes. It is neutral. The litmus test can tell us whether a substance is acidic or alkaline, but it does not tell us how acidic or alkaline it is. Chemists have now come up with a method using numbers called pH values to express how acidic or alkaline a substance is. The pH value ranges from 0 to 14. The lower the pH value, the more acidic it is. The higher the pH value, the more the alkaline it is. A neutral solution, neither acidic nor alkaline, has a pH of 7. At the end of this lesson, students should be able to relate the pH value with the acidic or alkaline properties of a substance. Relate the concentration of hydrogen ions with the pH values. Relate the concentration of the hydroxide ions with the pH values. State the uses of the pH scale.
What are pH values and what do they measure? Water, which is neutral, contains equal amount of hydrogen ions and hydroxide ions. Click on the spatula to add substance A, B, and C into the beaker of water. Note the relative amounts of hydrogen ions and hydroxide ions present in the three solutions. Now, match the solutions with the correct relative amount of hydrogen ions and hydroxide ions present in them. From the observation, we can conclude that solutions that are neutral contain equal concentrations of hydrogen ions and hydroxide ions. Solutions that are acidic have a greater concentration of hydrogen ions than hydroxide ions. Solutions that are alkaline have a smaller concentration of hydrogen ions than hydroxide ions. The pH value of a solution is a measurement of the concentration of hydrogen ions in a solution. The term pH is in fact an abbreviation for the power or potential of the hydrogen ion. It is measured using this formula. Thus, pH is determined by hydrogen ions concentration. Scientists have come up with a scale of pH values that range from 0 to 14. This range of numbers is called the pH scale. Let us find out what these pH values indicate. Click on sodium chloride solution, then sugar solution. The pH of sodium chloride and sugar solutions are both 7. At pH 7, the concentration of hydrogen ions is equal to the concentration of hydroxide ions. Therefore, a pH value of 7 indicates that a solution is neutral. Click on the acidic solutions. The pH values of all the acidic solutions are less than 7. At pH values of less than 7, the concentration of hydrogen ions is greater than the concentration of hydroxide ions. Therefore, a pH value that is less than 7 indicates that a solution is acidic. Click on the alkaline solutions. The pH values of all the alkaline solutions are greater than 7. At pH values of greater than 7, the concentration of hydrogen ions is less than the concentration of hydroxide ions. Therefore, a pH value that is greater than 7 indicates that a solution is alkaline. We have now learned how to use the pH value of a solution to determine whether it is acidic or alkaline. How else can we use the pH values of solutions? Let us find out by carrying out a simple activity. The pH of pure water in the container is 7. Let us see what happens to its pH as an acid is added to it. Click on dropper A several times and note how the pH changes as more and more acid is added. Do you notice how the pH value gets smaller and smaller as more acid is added? The pH of a solution decreases as the concentration of hydrogen ions increases.
We can conclude that the higher the concentration of hydrogen ions, the lower the pH of a solution. In other words, the lower the pH, the more acidic the solution is.
Let us now see what happens to the pH as an alkali is added to it. Click Clear before clicking on dropper B. Do you notice how the pH value gets higher and higher as more alkali is added? The pH of a solution increases as the concentration of hydroxide ions increases. We can conclude that the higher the concentration of hydroxide ions, the higher the pH of a solution. In other words, the higher the pH value, the more alkaline the solution is. Therefore, we can compare the pH of 2 or more solutions to determine which of these solutions are more acidic than the others and which are more alkaline. The pH scale is thus used to measure the degree of acidity or alkalinity of an aqueous solution. We have learned what pH values can be used for, but how do we actually measure the pH of a solution? We can measure the pH of a solution using an instrument called a pH meter. A pH meter is essentially made up of a pair of electrodes, an electronic circuit, and a readout device. Click the electrodes of the pH meter. Note the pH value obtained when it is placed in beaker A. We can also measure the pH of a solution using indicators. Indicators are substances that give a certain color in acidic environment and another color in alkaline environment. Different indicators change colors at different pH values. Litmus is a common indicator used in the laboratory. It turns red in acidic solutions and blue in alkaline solutions. It is colorless in neutral solutions. Methyl orange is red in very acidic solutions and yellow in alkaline solutions. It turns orange in color in neutral solutions. Phenolphthalein is colorless in acidic solutions and red in very alkaline solutions. Phenolphthalein are colorless in neutral solutions. By combining a mixture of different indicators together, we can get a solution that gives a different color at different pH values. This solution is called the universal indicator. We can therefore use this indicator to measure the pH of solutions. The universal indicator may be in liquid form or a paper which has been soaked in solution of mixed indicators. Let us now use the universal indicator to find the pH of several solutions. Click on the dropper to add a few drops of the universal indicator into each of the solutions, and then compare the color obtained with the colors in the chart given. Key in the pH values of the solutions. Try again.
Click on the names of the solutions highlighted in red to find their pH values. Then, determine whether the statements given are true or false. Good job. Try again. Good job. Good job. Good job. Good job. Good job. Try again. Good job. In this evaluation, the pH scale. In this tested on your understanding. We have learned that the pH scale is used to measure the degree of acidity or alkalinity of an aqueous solution. Solutions which have an equal concentration of hydrogen ions and hydroxide ions are neutral. They have a pH of 7. Solutions which have a higher concentration of hydrogen ions, hydrogen than hydroxide ions. Hydrogen chloride are acidic. They have a pH of less than 7. Solutions which have a higher concentration of hydroxide ions, hydrogen chloride than hydrogen ions, hydrogen are alkaline. They have a pH of more than 7. Finally, we also learned that we can measure the pH of a solution using a pH paper, pH meter, or universal indicator. Fish is very sensitive to the pH changes in water. It is important for fish breeders to measure the pH of the water in their ponds and carry out measures to maintain the pH value at the most suitable value. Conduct a case study to find out the optimum water pH for fish in an aquarium. In your study, find out what causes the pH changes, which pH is not suitable for the fish. Is the pH the same for all types of fish? And if the fish changes its behavior with the changes in pH, present your findings in class and produce a scientific folio.